We're going to extend our knowledge of functions just a little bit today. Let's go back and let's talk about what it means to be a function. And when I talk about what it means to be a function, I like to say a function is a rule that assigns people to the town they live in, or people to the town they were born in. Okay? And is it okay if multiple people live in the same city? Does that work? Yeah. Whole bunch of people live in Castledale, right? Some of them maybe we wish didn't live in Castledale, but that's not a mathematical argument. Okay? But can any person live in two cities? No. You either live in one or you live in the other. And maybe saying being born in a city makes more sense, right? If you're born in a particular city, then you can't be born in more than one place. So a function is a rule that says every x is connected to one y. But it is possible for multiple x's to be sent to the same y. So this one is a function. Okay. What about this one? Yes, that is a function. What am I not allowed to do? So if I send one x to two different y's, that is not a function. Okay? And we've reviewed that a little bit. Okay? Now we're going to talk about something called a one-to-one function. And a one-to-one function is necessary if you're going to do an inverse. Okay? And we have to understand why this is a problem. What's wrong with that? Why mathematically do we not like that? We don't like it because when I have an equation and I plug in x equals 6, I want my answer to f of 6 to be the same number every single time. I don't care what the answer is, but it has to be the same answer every single time. And if sometimes 6 gets sent to 4 and sometimes it gets sent to 3, that's a problem. So mathematically, we've decided x can only hit one y. Okay? And every one of these arrows moves to the right. Okay? But once we start talking about inverses, inverses are going to point to the left. Okay? Looking at, well, we got to throw this one out. This one is not a function, so we throw it out. Is there a problem with either of the other two in pointing the arrows to the left? Do you see any issues? So we're going to turn around and we're going to point arrows to the left on each one of these functions. What's the problem with that? Right here. Why is that a problem? When I do the inverse, one of the numbers that I'm sending to the inverse gets sent to two different places. And that's a problem. So as long as I move from left to right, I'm okay. But once I get there, if I turn around and go the other direction, then this is going to be an issue, which means this function is not invertible. Okay? So let's put it this way. How many of you are born in Price? Okay, so I make Tiana, you were born in Las Vegas, right? Las Vegas, and Kyson is born in Price. Who else was born in Price? Aurora. Aurora is also born in Price. Okay, so f, the function f, connects a person to their birth city. Okay, and that's a function. Every x is connected to one y. But what if I graphed f inverse? F inverse is going to do the exact opposite that f does. It's going to take Las Vegas and price, and it's going to connect them to people. And Las Vegas gets connected to Tiana. Is that a problem? No. But when I get to price, I get this. And so I say, okay, who does price get connected to? Sometimes it gets connected to Kyson, and sometimes it gets connected to Aurora, which means it's not a function. So the original function passes the test. Yes, it's a function, but the inverse breaks the function rule, and so it is not a function. Any function that can be flipped around and it's still a function is called a one-to-one function. What are the characteristics of a one-to-one function? How do you know if it's a one-to-one function? So, and we have to say the original is a function, and the inverse is also a function. So if we were to draw a one-to-one function like this, what's going to happen? What do we know has to happen? It would look like this. Do you guys understand why? So, if any x hits more than one y, it's not a function. But if any y gets hit by more than one x, it's not one-to-one. It has to pass both. Okay? So, let's look at a couple number sets. Is this a one-to-one function? Is it a function? It's not a function. Why? Okay. So, you can't say it is one-to-one because it works backwards. The definition is one-to-one function. This one is not a function. What if I were to switch this 3 with a 4? Now it is a function because we just restated 3 comma 4. Okay. What if I change this to 4 comma 5? Now it's a function, but it's not one-to-one. So in the original, one of the x's was duplicated, and that means it's not a function. And now one of the y's is duplicated, which means it's not one-to-one. So in order to be a one-to-one function, we would need to do something like that. It works from left to right, and it works from right to left. Does that make sense? So how do we tell if a graph is a function? Is that a function? Yes, because it passes vertical line test. Does this ever hit more than once? No, which means it's a function. How do we tell if it's a one-to-one function? Well, if we go back to this problem, what was wrong with that? Two x's hit, or one x hit two different y's, so it needs to pass the horizontal line test. Does this pass the horizontal line test? No, which means it's not one-to-one. So in order to be a function, you have to pass the vertical line test. In order to be one-to-one, you have to pass the horizontal line test. Can you think of any graphs that pass both the vertical and the horizontal line test? Every linear graph that has a slant to it, right? Does that pass the vertical line test? Yes. Does it pass the horizontal line test? Yes. Does every line do that? What about this line? Does it pass the vertical line test? Yes. Does it pass the horizontal line test? No. Okay, what about this one? Does it pass the vertical line test? No. It fails all over the place. Okay. What other graphs are one-to-one? An x to the third? Okay, and actually, x to the third graphs are really interesting. What about right here? How many times does that line hit? Once, which is kind of weird, but it hits exactly once. Okay. Some others would be, oops, the square root graph is one-to-one. 1 over x, this graph, it's one-to-one. No parabola is one-to-one. No circle is one-to-one. No x to the fourth graph is one-to-one. What's that? X to the third can be. So as long as it looks like this, the answer is yes. But some x to the third graphs look like that, and they fail the horizontal line test. So as long as they don't double back, right? As long as they keep going up or keep going down, then it works. But if they go up and down and up again, then it won't work. All right. So on this problem set, you are going to determine whether the given relation is a function. If it is a function, state whether it's one-to-one. And we're going all the way to, what did it say, 18? Okay. So graph those graphs in your calculator, and make sure, like on number 13, make sure the x minus 1 is in parentheses. Where do you find the absolute value button? Go into math, and then over to number, and the absolute value is right there. So you'll have to graph those. You might want to change your window to maybe -6 to 6, because some of them might be a little bit hard to see. So maybe change your window to -6 to 6, and you'll be able to see them a little bit better. Depending on your calculator, some of you do, some of you don't. If you're doing an absolute value and you actually see straight lines, you don't need to worry about parentheses. But if yours says ABS parenthesis, make sure you close that with another parenthesis. Yes. AAA. Yes. Actually, a bad